Hello, everybody. Today I will be presenting EASY. Today I will have a quick overview of what EASY is, how it works, and all the. For more detailed stuff will come later today. Presentations from Casper and Pedro. Okay. Let's start. So why did we wanted to make EASY? So there's a changing landscape of software installations. There's an explosion of available software. There's increasing demand for flexibility from scientists to move to the cloud from HPC laptop. There's also an increasing variety of processors and microprocessors from ARM to RISC-V, Intel, and it's no longer just Intel, but way, way beyond. In contrast to that, HPC teams are still rather limited. So they have an increasing demand, but the people who are working on it are still the same. And here we see a slide of like the software requests that we get at Ghent University. In 2024 it was even higher than in 22 and 23 that it's growing. What is special about EASY? With EASY we want to have optimized scientific software installations available to the scientists. And the importance of optimized scientific software is that if you're just installing a basic binary, then you're going to be on the right of the graph. But if you want, if you're going to have optimized, you're going to be in performance more to the right. And with EASY, we want to provide software that is on the right of this graph. So EASY in a nutshell, what if we no longer have to install a broad range of scientific software from scratch on every laptop, HPC cluster, or cloud instance without compromising on the performance? EASY in a nutshell. EASY in full is European Environment of Scientific Software Installation. It's a shared repository of optimized scientific software installations. It's also a uniform way for scientists and users to interact with the software that they want to use. So it looks the same on their laptop, in the cloud, or on an HPC system. It should work on any Linux distribution, including Windows subsystem for Linux, Lima, macOS, or other ways to have a virtual machine on your laptop. So it also supports different CPU architectures, interconnects, and also some GPU as well. And so we want to, because we are merging together the effort of building this software, we hope to be able to focus on performance, automation, testing, and collaboration on installation of software. So the major goal of EASY is to avoid duplicate work. So we already have tools out there like EasyBuild and Slack that make it easier for sites to install software, but they still have to put in the effort to install it. And this can, even though we have the recipes that make it simpler to get it installed, different sites can still run into trouble that other sites don't run into when installing the software. Another one is providing a uniform software stack so that the environment looks the same, exactly the same for people who want to use software, so that they, and without having to sacrifice on performance. And it's also handy for providing trainings for people on HPC sites, because you can help them get software on their laptop or readily available, and you can get them quickly working with new software and trainings. So a high-level overview of EASY. So we have the Hoste operating system, and on top of then we have the file system layer where the software is held, and then in the file system layer we also have the compatibility layer, which is like a basic OS where all the software, where it has the libraries that the software installed in the software layer is linking to. Around this, we also want to focus on testing, so we have a keyframe test suite for testing, and this is all provided to open software, to open source software, so EasyBuild, In the compatibility layer, we have Ghent 2, and for this file system layer, we have SermVMFS. And so we're already building for Intel, AMD, ARM, and RISC-V. So what is the goal of EASY in a bigger sense? It's so that you have applications such as Lamps, Espresso, and Wildbella, which you install in EASY, and it's available automatically will be streamed to all the EuroHPC systems. So it's already on Carolina, on Vega, on Mare Nostrum, and on Bucalion, and we're also closely working together with the other sites to get them installed there as well. And the the EuroHPC Federation platform will also help us in getting even more adoption among the EuroHPC sites. So let's do a hands-on demo quickly of EASY. So here I have a new machine. It was made a couple of minutes ago. So yeah, we have just a Python of the host OS 9.8. There's no modules there yet. There's no SermVMFS. Also no Git yet. So let me go to our documentation. So with these simple commands, you can get SermVMFS installed on a new system. So let me copy this. Now it's gonna take around a couple of minutes to get SermVMFS installed. I will let this run a little bit in the background, where I'll go a little bit more through my slides. We also have instructions in our documentation on installing it, on getting it ready on a Windows subsystem for Linux, and also with LimaCTL. What we're showing now is like a native installation for a single client. But if you're looking for it to get EASY on an HPC cluster, then we really recommend that you also have a mirror on your site and really build enough infrastructure so that you can provide the best performance of the software stack at your site. If we also did a tutorial on setting up SermVMFS for HPC sites, which was very well attended, and the recording and the slides are still online, and it's via the link here in the slides. And I will see. Okay, SermVMFS is now installed. So let me see. So now there's like nothing in this file, but it already exists. But if I now do and now it's like mounting the file system and gonna look. And so now we have EASY available on the system. So let me now set up EASY. So now it's setting it up on the system, and it's already done. So here we have a ARM Neoverse v1 system. So it's detecting the architecture for you, and also setting up then the right software stack for your system that will guarantee the best first performance. There's not any GPU, so I didn't really but if you have GPU combinations that are already supported in EASY, then you will also set up the GPUs at your site. You can also already have GPU software available. So now if I do, so now we have Git here, we have so we also provided a demo suite with and so to already see if the software is available. So let me quickly clone this. already. Okay. So here we have a bunch of examples. So let me, for instance, run the Chromax in here. So yeah, once easy is on this system, we have some here which quickly run. So yeah, let me quickly run this already. And so it's checking on which easy version you're at, and then loading the module that is. So now it's already running. It's very quickly because Chromax isn't that big, but if, for instance, we would run TensorFlow, it would have a little bit of a slower startup because it has to get so many files because TensorFlow has files in it. But it only has that startup period once. After that, it's in the cache and it will get quicker. And so now it's probably finished in a couple of seconds. Already with my slides again. So yeah, so then if I have it again. Okay. So if you have, you can also use easy in Slurm bash script, like here with lamps, if it's on your system. And so the easy experience in a nutshell is you search the init script, you load a module, and you start running. And what happens when you start running the software is SermVMFS will check the local client cache if it's already been used recently, already available there. If it's already available there, it will just start running on your system. If it's not there yet, then it will go to the mirror server and fetch the files from there. And the mirror servers are fed by a central server. And so you have Easy provides on-demand streaming of scientific software like Netflix or Pi. So how does Easy work? It's automatically streamed on demand via SermVMFS. It's independent of the host operating systems. So it's kind of containers without the containers, optimized specific CPU generations and specific GPU types. And it's initialized through an auto detection of the CPUs and GPUs of the system, so the users don't have to worry about trying to figure out on what kind of system that they are to get the best software available. This is an overview of our current infrastructure of our file system. So we have a central SermVMFS server in Groningen at the moment, and then we have also two mirror servers in Azure and AWS, and we also have a sync for people to sync their own mirror server, have one in the system. And then you also next to the mirrors, you can also have squid reverse. You can also have squid proxies and local caching. And then, you have it available on the cloud, on your computer, or on an HPC cluster. So the other layer we have is our compatibility layer, which holds small libraries that the software doesn't rely on the host OS, but only links to the compatibility layer. Then we also have our software layer. We now have support for NVIDIA GPUs under the accelerator subdirectory. At the moment we're only building with EasyBuild, but we're also looking in the future to building with PAC. So the current status of Easy. So we have our first repository in production, our first version. We have the software IO is now in production since November 2023. Right now we have only one version, but we're looking in getting the second version of Easy out there with EasyBuild.5 now released. We have Ansible playbooks, scripts, and docs available in our Easy organization. We have a Stratum Zero at the University of Groningen. And yeah, at the moment we have target for CPU microarchitecture. So we have ARM, NX86 generic. We have from Intel support for Intel and AMD, and then also ARM. Yeah. And we also have a limited combinations with NVIDIA GPU already available. I will show you the link a little bit later. And yeah, at the moment, for GPU, we're building now at HPC sites at Ghent and also at SURF. But for the CPU builds, we're still relying a lot on the credit from Microsoft and EUM' at the moment to build in the cloud. This is an overview of the software that is already in EasyBuild at the moment. So we have Espresso, Gourmet, Lamp, and as you can see, we steadily are growing since since the software easy.io was out there. So at the moment we have around 940 software installations available. And then we have around 467 unique softwares. We're building for a recent tool chase 2023 and 2023. And if you want to have a full overview of all the software that is out in EasyBuild, you can check our documentation in the overview page. So what are the supporting systems we already have? So we have x86, Intel, and AMD, also ARM. We also have a RISC-V generic software stack already ready to be used. Already also a very, it's already a substantial stack that we already have. And so we're also, and then with regards to NVIDIA GPUs, which we already have today, so we have combinations available of Zen 2 with an NVIDIA A100 and Zen 3 with NVIDIA A100s, and then we're also starting to build our stack for Zen 4 with H100s. Okay, and then we're also already we also started working on AMD GPUs, and hopefully those will also be coming to. They'll soon be supported to make it easy. Okay, then we also have built the software to allow for various interconnects, like NVIDIA, like InfiniBuild, using fat MPI libraries. So we also support for injecting vendor-provided MPI libraries if you want to have the MPI have easy software use MPI libraries that are available on your system. So our goal is to support all the architectures that are on your HPC system. So Easy is already available on your HPC systems, Vega, Carolina, and Italian. It's also now semi-natively installed via our simple Mare Nostrum 5, and you can also use Easy if it's not installed via certain VMFX on Ducalion, Discover, and Meluxina. We're also in close conversation now with Meluxina and EUM'25, and it's a work in progress there to get it also installed. And then, we'll also hope that Easy will be available from the start when Jupyter launches. A couple of months, I think. And then on non-your HPC sites, it's already supported at sites in the Netherlands, such as SURF on Snellius, but also in Belgium at some VST sites, and Sigma 2 in Norway. And if you know of other systems where Easy is already available, you can also add new systems to our system page in our documentation. Okay, so for NVIDIA support in Easy, we had to do some tricks because the compiler of NVIDIA is not open source, so we're only able to provide the runtime, the CUDA software, but we're not allowed to ship the driver libraries. So what we did is you can link your drivers via when you set up NVIDIA GPUs on your system, you have to tell Easy where it can find the driver on your host OS. And the software that the software that we already have available for GPUs are CUDA samples, Espresso, LAMP, and CCL, OZU, microbenchmark, and we're also working on PyTorch, TensorFlow. Hope that will go between soon. To have we also wanted the collaboration to get more software into Easy, so we have set up a semi-automated workflow on adding software into Easy. So if you're a contributor and you would like to have a specific software available in Easy and it already has an Easy config, then you can simply create a PR to our software layer, which can be very simple, just a single line, adding a single line in a YAML file. Once the PR is there and the reviewer says okay, then the build bot will submit jobs in our build cluster, where it will build for the different architectures that is already available. There's a full list. Once the build is done, it will run the tests that are available via sanity check in EasyBuild, but on top of that, it will also run a reframe test. If the build is all okay, the tests are okay, and the software is ready, it will move the tarbos of the software installations to a S3 bucket, and a cron job will then pick it up for the Stratum zero server. It will open a PR in our staging, in our Easy staging. Once it's done, it will be deployed and Easy, and then it will become automatically available on all the sites where Easy is available in minutes or hours, depending on how you've set Easy up. So as I mentioned, software testing is very important. It's an important part of Easy. That's why we built our own test suite with Reframe. You can find the documentation on the test suite in our documentation. And so the things we wanted to focus on for our test suites is that's a collection of portable tests for software that is available in Easy. We're also running the tests periodically, daily, on a weekly and daily basis on different systems. And we're also running the test suite after building software and before deploying it. And our test suite is not only for the Easy software stack, but you can also use this for your local software stack. At the Ghent, for instance, we're running it periodically on our local software stack as well. We've also discovered through the testing, we've also discovered a bug in GROMAX, which they hadn't caught before, and because they don't have testing facilities for all the architectures that we support, so we're also helping developers in catching bugs when they pop up for specific architectures, we hope. Like this case, we hope that there will be more developers who will come to us that it can be going back and forth between the developers and us to get the best software out there for the users, have less trouble with users that can't get their software installed. We also have a dashboard already. So here you can see an overview of the tests of TensorFlow running at the Rome partition of Snellius, and you can see the different scales that it's running on. Here you have a full overview, it's a little bit messy, of all the systems that we're already testing right now. This is just for the LAMP test. So we're collecting that we allow people to submit their data that comes from their own system that push into our dashboard. So in the afternoon, at 1:50 to 10, Casper will do a hands-on session to get a configuration hands-on session with the test suite to get more people ready to start using it. For that, he had some things like if we could set it up on your own HPC system, that would be great. So if you could reserve like one CPU node already by the time of the session, that would be great. It's also possible to do just it on your local laptop, but then you have to have one of these modules available. If you don't have any modules available yet, it's easiest to install Ozu with Easy because it's a fast installation. So what are some easy use cases? So one of the easy, So it's a uniform software stack, and you can also use it, for instance, in portable workflows and continuous integration. So to have more of a collaboration of software developers. And so if you're, for instance, a developer and you want to test your software, but it relies on a lot of dependencies, that you don't have to install those dependencies in your workflow, but can simply rely on Easy, get the dependencies, and then test the software that you actually want to test out there. We also have a, so Easy has a uniform software stack, so it's the same software everywhere on your laptop, but focus on performance and facilitates migration. So on workflows, as I told. So leveraging Easy in your CI environments. So we have an Easy GitHub action which installs SermVMFS in your action and then makes all the modules and sets up the environment in the action so that you can simply do a module load of, for instance, PyTorch if your software depends on it, and then test your software on top of it. So this is how one of the CI environments looks. And so this is Easy in action in a GitHub action. We have some examples out there if you would like. For instance, here, it's not this one. And then Easy is also easy to facilitate trainings. We also work together with Magic Castle to have like throwaway Slurm clusters in the cloud. If you provide cloud access to, for instance, training session, it's easy to have a lot of software readily available to the user fastly if you rely on Easy to get during those trainings and provide easy participants. We also hope for more collaboration between software developers and experts. Okay, so Pedro will have more on detail on dev.easy.io later today. For instance, on Vega, so if SermVMFS and Easy are set up on your system, you already have access to the dev.easy.io. At the moment, we're keeping, so what we want to have with dev.easy.io is that developers can have like, pre-releases that they can build and test on HPC systems. At the moment, we're limiting this to the test cases within the multi-xScale project, but for instance, lamps installations with new plugins that are being developed within Easy that become accessible on Vega and can then also be tested. So we're very proud that Easy is already recognized by the community through the Fire Award. And yeah, he also voted for us. So we'll also have some webinars, 5 Mondays in May and June on specific subjects related to EASY. So we'll have another tutorial on ServVMFS at HPC sites. We have an introduction into EASY, and then also on using EASY on top, using EASY as a base system software. As a base system stack, and then building on top of it with, for instance, Easy Extend. Then we'll also do an introduction to EasyBuild, which will also touch on the new features that have come with EasyBuild 5. And as last, we'll do a tutorial on CI/CD where we'll touch on, for instance, the dev.easy.io. Yeah, more on this will be announced shortly. We also have support to the multi-xScale project of EASY. So if you have questions, you want new software in there, you can you can send us an email via support@easy.io or visit our GitLab. Yeah. Okay, so this was a tutorial that we did on the best practices for ServVMFS in HPC. The recording and the presentation are still available online, but in May we'll do a new iteration of this one. And then this was our EASY paper that we did in 2021, showing the possibility, showing the a proof of concept of what EASY could have been. And then I'm finished.
There's a question online. How hard or easy is it to use EASY together with using LMOD for local modules created by EasyBuild or custom modules? So how hard is it to combine EASY with stuff you have installed locally as well?
Not yet.
Yeah, I guess it depends on how it's installed. You do have to be careful.
Yeah. I mean, mixing is difficult. I mean, in the EASY sense, if you take a binary from EASY, it will work. But if you try and take a library and mix that with something that's local, that's not going to work, right? Because you're effectively mixing two operating systems. So the easiest approach is to separate them as different software stacks, right? Either I'm in this software stack or I'm in the other software stack. That's the simplest approach. Other things, it is possible, but then you have to be careful, and sometimes it's hard to be careful, right?
And it is actually more likely that things will work because we heavily rely on RPOD in EASY. So loading modules in EASY is not going to break local stuff. And also the other way around, it should be okay. But as soon as you start mixing tool chains, it gets messy.
Yeah, and even things like Python modules. If I install a Python module, which Python am I actually using? And then which Python modules is it using? Are there something compiled in there? It gets complicated.
EASY uses LMOD. It ships LMOD as well. So even if you don't have LMOD on your system, you're getting it through EASY. Yeah, it's part of this middle layer.
What if I only wanted bio?
So that's one of the things I'd like to see maybe somebody else do is to implement these kind of things, because there are I was talking about this yesterday. There's this concept of categories in LMOD, and so you can create a lookup table and say this is in this category, right? And then you can say only show things in this category, right? And so you can create a user perspective, different perspectives even, on that software stack. And in the LMOD sense, everything is visible to it. So the loading dependencies and all that will happen just fine. But what you present to your users will be different, because you might do that on the basis of a category of things that you are interested in. But what I don't think we should do is bake that into the modules themselves. I think that's something that's either we do something as a community and create these categories and put things in different categories, or you do it locally. You could take what we could do something globally, and then you could take what you want from that, right? You can modify it any way you want, because you might want to do that anyway, because if you extend beyond then you have new software that you also want to categorize, and it's not in the table, right? So you may need your own table on top.
More questions online. How does Easy know how to load the right toolchain for a specific machine, including vendor MPI, network libraries, and so on?
For the vendor MPIs, you can link to the MPI that you want via, I don't know.
Host injections.
Yeah, via host injections, you can do that with like,
So I mean, so somebody from Do It Now is working on a script that will help to automate this a little bit for you. So you just point it to the open MPI installation that you have, which is ABI compatible, and say inject this, and then the script will do the complicated work. In terms of the tool chain, we are the ones providing the tool chain. So we're not taking the tool chain from the system. We're providing the tool chain. The only injection you can do is at the MPI level at the moment.
So out of the box, you get an MPI that's not tuned to your system, but you can plug in a different one, and as long as it's compatible with the one we built against, that will help. And that's where the common API that Jeff talked about yesterday for MPI is going to be really helpful, because we can build against one API library with the common API, and then as long as your MPI library implements the same API, you can just plug it in. So that will be very helpful in the end. Yeah.
Okay. So we've already heard that our users are always very impatient, and Easy release is now based on 2023B, I think I've seen, and it's 2025 now. So do you have a policy for fixed toolchain updates? And the second part of the question would be, could I use some of the tooling to just rebuild the packages with a newer toolchain locally on my cluster?
Yes, you can. Yeah, I think we will start building 2024A and 2025A once we have the new compat layer that's already being built at the moment. So we hope to get it out there soon. Yeah, you can rely on the things that are already available in Easy, and then build a new tool chain on.
I mean, maybe just to mention, I mean, the reason that maybe we haven't taken up 2024A is we've deliberately been holding back because we were waiting for EasyBuild 5, so that we could start a new release, and then we wanted to move the new toolchain to the new release because that allows other possibilities as well.
We're going to try and keep toolchain generation specific to a specific Easy version. So we'll keep doing 23B in the current version of Easy, which is 23.06. And we're kickstarting a new version of Easy, and there we'll start 24A, and newer toolchains go in there. So we're trying to keep that split. That makes it a bit easier for us. Yeah. Yeah, and there's a related question online. Is there a policy in place for how long Easy will keep repository versions available?
I think we want to keep them as long as possible for providing reproducibility to scientists. I think if it's like very long, we will like the oldest version, we would maybe package in like a container so that it's still possible to use them, but they won't be available in the main repository anymore. But we really want to make sure that they stay as long as possible.
Yeah. And thanks to the mechanism we're using, like controlling our own glibc, we should, I mean, time will tell, but we should be more able to keep things alive and available for a longer time. Yeah. Last question, yeah.
Your big sales point is the claim of optimized software. Now, optimizing software is a lot more than making sure that -m arc equals native minus O2 is set when compiling applications. You like the example of Gromax. I can tell you, when I was responsible for the software stack in Antwerp, I got 10% better performance out of Gromax by not using the EasyBuild compiler options, but the ones that are building Gromax. So that's one aspect. Second aspect is there's more to, I mean, you need to interface to the system also. If you run at the scale of Lumi, you may have I/O libraries with explicit support for Lustre or for BGFS or whatever parallel file system. So you want that to be compiled then. If you look at MPI, running at scale on a machine like Lumi sometimes means that you need to do particular settings inside MPI, for instance, different choices between different collective implementations. That's how Craig got their CP2K benchmark on Lumi running properly. So there is so much more about optimizing. Actually, I could go even a step further. It is even on the scale of Lumi. It is even making sure that you have a distribution mechanism that doesn't cause additional OS jitter that can break scalability of applications. So I think there is a lot more to look at before you can claim to be truly optimized. No, it's like, okay, we try to make sure that it's optimized for the CPU, and even that is not completely true. But that's where the claim of optimized stops. So I think you have a lot of work to do in that respect before moving to other systems.
Yeah, I think we also don't want to claim that we have like the best optimized, because we can't. For every scientist, they will want something different to make it even more optimized for them. So I think with like the software, being uniform, we can't like promise the best software for each and every single scientist. But we can have like the base layer for them. And so if they want to optimize the software that they're using even more, they can just build on top of Easy and rely on the base software stack to get the full performance that they want for it.
We have to be careful on time, but
Yeah, I mean,
just offering Easy may break other applications.
yeah,
If the
if that
distribution
happens, that's a
mechanism
problem.
turns out to add OS jitter, then it may break other applications.
The way they're going to do it on Lumi, there will be no jitter because they won't install
won't be a
CVMFS on the
service.
clients.
there won't be a service on Node.
I would hope they do it via DVS. That's usually what's advised, or that they will copy the software stack. I don't
Yeah,
know
that's
which
what
of
they're
the two
doing. They're
approaches
going to
they are
rsync
looking
it to
at.
Lumi F and then just create the symlink and it will come in through Lumi F. So OS jitter-wise, CVMFS will not be on the nodes. Yeah.
But just to make a couple comments on that comment, right? So, I mean, you can squeeze an extra 10% out, but in the easy approach, then it makes like you have knowledge, right, that you could contribute back, right? So instead of like going outside the ecosystem and doing it yourself, you could instead go inside the ecosystem and try to make the improvement there, and everybody benefits, right?
I mean, honestly, my experience is that it's serious.
Okay.
Contributions.
I mean, contributions of who? Of whom? What do you mean contributions?
When I was working on the software stack in Antwerp, our contributions were not taken seriously by EasyBuild people.
Okay.
Don't know what that means.
Tried to contribute, then we've given up.
You've given up on contributing back because the feedback is
Stefan also said, look, we stop doing that. We just do our own thing.
okay. That's not good. Yeah, then we need to continue that conversation for sure. Yeah. I wasn't actually aware that that happened. Yeah, but still, I wasn't aware that there was a stop. Yeah. Kaspar, make it quick because you're stealing your own time.
Just as a remark to this, I mean, if there are things that you can do that are very system specific, it will never make it back into Easy or EasyBuild, right? So I don't think we'll claim that we'll ever reach that level of optimization. I think it will always be a trade-off between user convenience and optimization. And I think with that, like at least we can get something to, let's say, the 90% of users that would not be able to do better themselves. And they could use it very easily. And then the 10 or even 5% of users that can do better, they could use it as a basis or still completely do what they do now and build from scratch, right? So I think that's sort of the goal that we have.
Yeah, I think this is perfect for lunchtime and coffee break discussion. So let's not go off the rails too much during the schedule and continue.